Lesson 8.1 is graphing linear equations. And in the scenario we have here, they're talking about how light travels faster than sound, and there is a linear relationship between the two. So you're always going to hear the lightning. It's always going to be a certain number of seconds between the lightning and when you hear the thunder. And if you were to graph it out, you would see that there's a linear relation. So if you see the lightning, hear the thunder after a second, you'd plot that. See the lightning, hear the thunder after 2 seconds, you'd see that there's going to be a linear relationship between the two. So a linear equation right here, underline this please, is an equation whose solutions fall on a line in a coordinate plane. So they have to be plotted. When we plot it out, all these points have to lie on the same line, otherwise it's not a linear equation. All solutions of a particular linear equation fall on the line, and again, all the points on the line are solutions of the equation. So if an equation is linear, this is very important. A constant change in the x value corresponds to a constant change in the y value. So in other words, if x always changes by 2, y always changes by 5, that's a linear relationship. But if x sometimes changes by 2 and then later it changes by 3 and y changes by 4 and sometimes it changes by 7, that's not going to be a linear relationship. And here's just an example showing what a line could look like. It's showing that the x value increases by 3 and the y increases by 2. We generally look at it as a rise over a run. A rise over a run. So my steps are going up rather than underneath. All right, when we graph these equations, we can decide whether or not they're linear by actually looking at the graph. When you're going to make the graph, the first thing I want you to do is make a table. So we're going to make a table. We get to choose the x values. I'm going to have you choose -2, -1, 0, 1, and 2. We've done this before, and eventually you can choose your own, but for now, so that we're all together, these are the values that I want you to choose. And then we're going to just simply put these values into the equation. So first I have y equals, my first x is -2, so I have -2 times -2 for the x, minus 5. Y equals +4 minus 5, so y equals -1. And I put that right here. I'll do the same thing with the -1. So I have y equals -2. Now I substitute in the -1 minus 5. So 2 times -1 is 2, minus 5 is -3. Whoops. And I'll put in 0. So -2 times 0 is 0, minus 5 is -5. And as long as we're establishing a pattern here, the x is changing at a constant rate, I can see that the y's are changing at a constant rate, and in fact it looks like they're decreasing by 2. So this is -7, this is -9. Now I'm going to graph this out and see if it's linear. So I have -2, -1. Notice that my scale is going in twos. I have -1, -3, 0, -5, 1, -7. Oops, that was not a 1, was it? There's 1, -7, and 2, -9. And now I can go ahead and draw this. You can definitely tell it's linear. There's no curves in it. So I want to go ahead and draw the line, and I'm going to draw it so that it has an arrow at both ends, because technically it does keep going. I only plotted these 5 points. Let's go ahead and check out this next function. Again, I'm going to do y, or x and y, -2, -1, 0, 1, and 2. And I have y equals negative, and then my x is -2, so -2 squared plus 1. So y equals -2 squared, I do it's in parentheses first, is +4, but then this means take the opposite. So I have a -4 plus 1 is -3. I'll do the same thing with the -1, so I have y equals the opposite of -1 squared plus 1. -1 squared is 1, but the opposite is -1, plus 1 is 0. When I plug in 0, The opposite of 0 squared is still 0 plus 1, so I get a 1. I don't really see a pattern here as far as adding or subtracting a constant value. So I'm going to go ahead and figure out at 1. There is going to be a pattern, but it's not going to be a constant change for the y, because from negative 3 to 0 is a move of 3, but from 0 to 1 is only a move of 1. So I'll put in a positive 1. So I have the opposite of 1 squared plus 1. Well, the opposite of 1 squared is negative 1 plus 1 is again 0. And then finally I'll do the same thing with 2. The opposite of 2 squared is negative 4. Negative 4 plus 1 is negative 3. So you see there is a pattern, but it's not linear, and you'll see that when we graph it out. So I have negative 2, negative 3, negative 1, 0, 0, 1, 1, 0, and 2, negative 3 again. So when I graph this, it's definitely a curve. And again, put arrows at both ends of your curve. So linear over here, x and y change at a constant rate, not linear here. X is changing at a constant rate, but y is not. And that leads us to our next section here. We have, I need you to fill this in. It's a rate of change, so fill that in, is a ratio, so remember it's a fraction, that compares the amount of change in a dependent variable, that's the y, to the amount of change in the independent variable, that's the x. So then you can go ahead and fill this in. Rate of change is the change in the dependent variable, and we're going to, I want you to write this down, but it's a shortcut. This means the change in, so this means the change in, and this is the Greek letter delta. It's not really a triangle. So it's the change in y divided by the change in x. That's our rate of change. And here they want us to determine whether the rates of change are constant or are they variable. Do they change? So I'm going to go ahead and figure this out. The change from 3 to 4 is add 1. 4 to 5 is add 1. 5 to 6 is add 1. 6 to 7 is add 1. So it looks like my change here is constant for the y's, but I'm looking for the rate of change. So my change in x, from 0 to 1 I add 1, 1 to 2 I add 1, 2 to 4 I add 2, and 4 to 5 I add 1. So it's not a constant rate of change because of this part right here. Everywhere else it was 1 to 1, but here now it's 1 to 2. So this is a variable change. So if I were to graph this out, it would not look like a line. Let's try this one. 7 to 9 is a change of 2. 9 to 11 is a change of 2. 11 to 13 is a change of 2. 13 to 17 is a change of 4. That doesn't mean that it's variable. We have to check out here and see if the pattern holds true. 2 to 4 is a change of 2. 4 to 6 is a change of 2. 6 to 8 is a change of 2. Oops, that's a 2. And 8 to 12, oh, that's a change of 4. So this is 2 to 2. All these are 2 to 2. This is 4 to 4. But that does give us a constant change. They're changing by the same amount. So this is a constant rate of change. So this would be linear. So let's go ahead and write that for both of these. This is nonlinear. And this is linear. All right, last one. We have a real estate agent. Their commission may be based on this equation, C equals 0.05S plus 500. So 500ths of the dollar amount of sales is what they get, plus an additional $500. And commission is money that real estate agents make. It's like their extra pay that they get. Car salesmen also get that. Salespeople in the store, they sometimes work on commission. So the first thing they want us to do is figure out the commission if they sell a house that's $125,000. So we go C equals 5/100ths times $125,000, And we know that 5/100ths is the same as 5%. So they get 5% of the sales price, plus they get an additional $500. So when we do this, we have 125,000 times the 5% is 6,250 plus the additional 500. So this person is going to make $6,750 in their paycheck for selling that $125,000 house. So if you're good at sales, might be a good profession for you someday. Okay, now they want us to graph it and tell whether or not it's linear. So instead of doing an X and Y, I'm going to do an S for sales, that's my independent variable, and a C for commission. I have to understand that when I'm looking at my scale, this 50 means $50,000, $100,000, etc. So I'm going to do this starting with 0, and I'll go up in steps of 50. But when I plug it in, I'm plugging in 50,000, 100,000, 150,000, etc. And I have to understand that my answer is going to come out in thousands. So if I plug in 0, I end up with just $500. Maybe that's just saying, okay, sorry you didn't sell anything this month, but we'll at least give you $500 for working for us. So if I do 50,000, then if I take the 50,000 times 5%, I get 2,500 plus an additional 500. So you're going to make 3,000. Then I'll do 100,000. And then plus 500. 5% is going to be 5,000 plus 500, so the commission is going to be 5,500. And the commission for 150,000 is going to be 8,000. So you can see here, whoops, I did not put the right, there's 5,500. You can see here that we do have a pattern. We are adding 2,500 every time we go up in sales by 50,000. So that right there should tell us, yes, it is linear. Let's go ahead and graph this out. At 0, it's 500, so that's half of 1,000. At 50, it's 3,000. At 100,000, it's 500 or 5,500. And at 150,000, I found that it was 8,000. And then when I graph this, this is technically only a line with an arrow at the end. And I'll explain that in just a minute. So it's going to look like this. So it's definitely linear. This is actually array because it doesn't make sense to graph anything in these other two quadrants right here, or this third quadrant either, because you cannot have zero sale, or negative sales I should say, and you cannot make negative money. So here is your video, and I will go ahead and post the assignment online so that you can